Hello, Environmental Biology 105. My name is Matthew Newell. You could probably deduce that from the name, I think, on the post. Um, yeah, I decided to do my poster and speech on nuclear energy. First, I have to say that I haven't really maintained that much of a presence, so to speak, in the class. I guess I like doing the work, but I'm a little bit, what is the word, shy? God, it sounds so derogatory. It's almost like a curse word, shy. But yeah, so also I'm not really doing a video. I'd rather just do audio with this lovely microphone here. Um so without uh further ado, I'll start on my nuclear energy speech. Here's a little bit of an introduction. Why I chose nuclear energy is that as far as sustainability is concerned, there's multiple things you could do. There's a vast number, but I think that nuclear energy is the keystone at this moment, especially in our human societies. It is the most imperative at the very moment because we are on a sort of precipice and we're going to have to figure out what we're going to do. And I think that nuclear energy, personally, is the most pragmatic method. So I'm going to deal with first going through the poster, but a little bit more. What nuclear energy is, how it's made, and whatnot, our human consumption of it, and how it can help us. Then why not? What are the controversies behind this? And then just a little bit of an outro. All my sources are going to be made available. I have about 7 of them, I think, not including the graphs and whatnot. So, first, the two types of nuclear energy. You have fusion, which is where you put deuterium and tritium, two hydrogen isotopes, throw them together, and boom, you get energy. And, of course, another neutron and a helium atom. And you get a lot of energy, like a lot. You have 10 million, sorry, tons of energy produced from that. We don't really use fusion that much because it's so freaking dangerous. We tried it a lot back in the Cold War. If you've heard of Tsar Bomba, that was the big Russian test. Yeah, we don't really use this especially for power. We use fission for power because we just cannot control this one as easily. And ultimately, we're going to try to use it more. The other, of course, contrasted is fission. That's where a neutron it bombards either uranium-235 or 238. Either one is viable. It just depends on what is available. And then of course, you have a big explosion, 20,000 tons of TNT. That is what we used to bomb the Japanese, regrettably, back in the end of World War II with. So there's the two types. We'll be going over, think about fission in all these contexts because fission is the one that we're using most often. So you'll see the graphs. The one at the very bottom center, the big one, that's our increased use of nuclear energy, the world's use of nuclear energy. And you can see there that it's gone up for a while. That is because this has become far more pertinent, and what a lot of people don't realize is that it is pertinent. And at the very bottom left, the really tiny one, it really wasn't necessary to make large. I had to conserve room. That's the U.S. Supply and demand of nuclear energy. But as you can see, the demand in the blue is a lot higher than the supply. And we're trying to remedy that, but it's taking quite a while. So, yeah, we really didn't get very far for the first couple thousand years of our human expansion, and then suddenly, in about 100 years, we took off. We blew up, so to speak, in our expansion, especially of our energy consumption. And that has been very, very, very promising for the survival of our race because we want to survive. But it's also been a little bit detrimental in some ways. And detrimental in the way that with all these new discoveries of energy, we halted at some point. We found new ways, but we weren't properly utilizing them. Other ways seemed a little bit inefficient. So we started being practical and just started using up all the coal and oil that we found. And that's what we're still doing to this day. And it's going to work until it doesn't work. And as of right now, we have 0.2% of the world's energy being on solar, and nuclear energy is 11% of it. The rest is hydro energy, wind energy, and of course the biggies, coal and oil. And especially especially because those are the two most practical immediately. We don't have to bombard little atoms. We can just burn things, which we humans like doing. But that's only going to work for so long. And so, really, this is the reason I argue for nuclear energy is because it's so incredibly practical. It is the most practical. Until a messiah comes along. Hopefully, we don't nail this one to a board that shows us how to make sustainable energy, which may or may not happen. We're going to need nuclear energy. So that being said, let's talk about some of the potential consequences. This is the biggie. A lot of people anathematize nuclear energy to make it an enemy, as we can see in those two nuclear reacting coolant towers in the picture, the main picture. That's not pollution. That's steam. But a lot of people don't. I'm very aware that a lot of people don't know that. The pollution is an issue. The pollution is an issue because we need something to do with the radioactive waste. We can't just toss it about. We have to put it somewhere. A lot of times we're storing it in trash bins at the bottom of deep pools, and that works to an extent, but we only have so many pools. We have to do something with it. So normally, as of right now, we're just burying it as well, which will ultimately infect our groundwater. So there's not really a good way to deal with that. When things blow up, as we've seen with Fukushima, 3 Mile Island, and Chernobyl, things can go really, really, really wrong. So, and then of course the accidents that do happen, there's a little science to it. I found probabilistic risk analysis estimates that put that on my chart. 2 out of 3 meltdowns there will be no deaths. 1 out of 5, 1,000 deaths, and 1 out of 100,000 accidents there will be 50,000 deaths, and going and going and going. But it really is utilitarian. We need to do it just to save ourselves. So that is my little speech on nuclear energy. You guys hopefully will take the time to make calculated, informed, well-researched decisions on your stance on that. Thank you.